Today we are presenting our COGS 200 project, Cross-Linguistic Cognitive Bias in Large Language Models. Our core research question is, do LLMs show different degrees of cognitive bias depending on whether they are prompted in English or Chinese? Now the motivation for our study. LLMs are increasingly used in large stakes contexts like medicinal, financial, and legal decision support, and they are being used globally across many languages. The problem is that almost all existing bias evaluations are conducted exclusively in English. If cognitive bias in LLMs exists and it varies by languages, we cannot assume fairness for non English speakers based on English test results alone. Our hypothesis is that bias rates will differ across prompt languages, driven by differences in training data composition and linguistic framing conventions. We tested two cognitive biases. The framing effect is when the same information presented differently leads to different decisions. For example, an outcome showing as saving 200 out of 600 people versus letting 400 people die leads to different choices even though the math is identical behind them. The sunk cost fallacy is when prior irreversible investment influences a current decision even when logically it should not. We tested four leading multilingual models: ChatGPT, Gemini, Qwen, and Claude. Qwen is the only model developed by a Chinese company, making it a particularly interesting data point for cross-linguistic comparisons. So the method and the experimental procedure we used is as follows. We adapted a classic research paper in using match pair design, where each model picks option A or B. All questions were translated from English to Chinese through forward and back translation by bilingual team. Each prompt was run 3 times per language in a fetch conversation thread to eliminate memory effects. This is our Excel sheet where we input all our results and it calculates bias. Here's how it works. We gave ChatGPT a positive frame and a negative frame. On the right is a negative frame. The numbers are mathematically identical, but the model gave different answers, and this is what framing effect is. So the results are framing effect. 3 out of 4 models exceeded our 15% significance threshold. Claude Sonnet showed higher bias in English at 44% versus 22% in Chinese. Gemini 3 went in the opposite direction, where it showed more bias for Chinese. And ChatGPT did not show any meaningful difference as both of the percentage were 39. The key finding is that cross-linguistic differences are real and significant, but the direction is inconsistent. This is architecture specific rather than a universal LLM property. These are the results for sunk cost fallacy. No model came anywhere close to 15% threshold. Bias rates were near zero across both languages for all 4 models. This is a meaningful finding in itself. For our discussion, so first, framing bias differences are architecture specific and they are not universal. Second, near zero sunk cost fallacy results likely reflect training data exposure to these classic scenarios, and more fundamentally, sunk cost bias in human is emotionally driven, and LLMs do not have emotional mechanisms to trigger it. Thirdly, cross-linguistic framing differences may reflect how emotionally loaded language is distributed across training corpora. Fourth, we cannot rule out that some rational looking response reflect pattern recognition rather than genuine reasoning. For evaluation, our match pair design isolates the manipulation as the only variable. Running each from 3 times with majority vote reduces stochastic noise. Fresh threads eliminate memory confounds. Forward and back translation verifies semantic equivalence. And our 15% threshold was set before the data collection to prevent post hoc bias. The main limitation is training data contamination. Our results should be treated as exploratory given the small sample size. For computer science, we contributed a replicable cross-linguistic bias evaluation framework. From psychology, we showed how the human emotional mechanisms do not simply transfer to LLMs. Future directions could include novel stimuli, more language pairs, and a larger sample size. The impact. The real world implications are pretty straightforward. Chinese speaking users may be receiving systematically more biased outputs from the exact same model. Gemini 3 is the clearest example, where the bias for English was 22, but for Chinese it jumped to 67%. The gap matters in high stakes applications.